All right, we're finishing the S5, S10 review number 1 video. Okay, so we're on the third side of a page. Rosa joins a club, and she's preparing to run a marathon. During her first training session, Rosa runs a distance of 3,000 meters, and in the training session, she increases the distance she runs by 400 meters. Okay, so this is an arithmetic sequence because we just keep adding a constant value. Here are formulas defining the nth term and the sum of the first n terms. So question 1, find the distance Rosa runs in the third training session. So I'm going to use this formula right here. I'm going to replace n with 3. We know that the distance keeps increasing by 400, so my d value from here is 400, and we know our first u1 value is 3,000 meters, because that's what she started running the first time. That simplifies to this. Write down the distance Rosa runs in the nth training session. So I'm using this formula here. I'm replacing U1 with 3,000. I'm replacing D with 400. There is my formula for the nth training session. Okay, question C. A marathon is 42.195 kilometers. In the kth training session, Rosa will run further than the marathon for the very first time. Find the value of K. Okay, so 42.195 kilometers, you move the decimal 3 places in order to get meters. So we need to make sure we're in the right units first. So we want this value to be less than this here, because once n is greater than this, she will have run further than this length. So once this right side of the equation is greater than this value, at that time she will have run a further distance than this. Okay, so now that we've set this up using u sub 1 being 3,000 and d being 400, now we can subtract 3,000 on both sides. We get this. Then we divide both sides by 400, we get this. Then I add 1 on both sides and we get this. So we know that n is greater than this value. So 98.9, in order to be greater than that, n is going to have to be 99, because this is going to be greater than this value here. Okay, 9D. Calculate the total distance in kilometers that Rosa runs the first 50 sessions. Okay, so now I'm going to use the sum formula because we're trying to figure out total distance. So, and we know that n is 50. We know u1 is 3,000. N is 50. D is 400. And now we just simply put this through and solve it. You might want to hit pause. Okay, next. Part E. Carlos joins the club to lose weight. He's run 7,500 meters during the first month. Then the distance he runs increases by 20% each month. Find the distance Carlos runs in the 5th month of the training. So my R value is 1.20. How did we get this value? This is 100% plus 20%. So 100% plus 20% gives me 1.20. Okay, so to find the distance Carlos runs on the 5th month, we're going to use this value here to find out, and we're going to replace the n with 5. So we're replacing n with 5. U1 is 7,500, and R is 1.2. And we put into the formulas, and we get this. Calculate the total distance Carlos runs in the first year. Okay, so in a year, we know there's 12 months, so n is 12. And so I've got, we're using, this is geometric, correct? Because he's increasing 20% each time. So that means it's geometric. And I can use either of these formulas. So in this example, I'm using this one here. And am I using that one? Actually, it looks like I used this one here. Okay, anyways. So we simplify this, and did I do something wrong here? I think I see what I did. If this minus 1, the denominator here is switched. I did 1.2 minus 1. I wrote down the formula incorrectly. Okay, there we go. Now it's right. Okay, I knew something was funny here, fishy. So I did r minus 1, so 1.2 minus 1 in my denominator, and then I end up with 0.2, and then we simplify and we get this answer. Okay, next page. Okay, the Meteorologist Model, so the height of a hot air balloon launched from the ground. The model assumes that the balloon travels vertically upward and travels 400 meters the first minute. So due to decreased temperature and as the balloon rises, the balloon will continue to slow down. The model suggests that each minute the balloon rise will travel only 82% of the distance traveled in the previous minute. Okay. So if it's only increasing 82% each time, that means my R value is 0.82. Okay. My U1 is 450. Find how high the balloon will travel in the first 10 minutes after its launch. So how high it's going to travel is going to be a sum. So if I'm using sum, I have to use one of these two formulas. Okay. And so using that formula, I'm replacing U1 with 450, we're replacing N with 10, and R with 0.82. And then we simplify. The balloon is required to reach a height of at least 2,520 meters. Determine whether it will reach this height. Okay, so I'm going to use my infinite geometric sum to see if it will ever reach that height. So my infinite geometric sequence formula is this. I'm replacing U1 with 450 and R with 0.82. And then we get this value. And so is this value as high as 2,520? No, this is less. The balloon is not going to reach its required height. Okay. Suggest a limitation to the model. So is this model the best? There's various things in life that could change it. So the wind, the rate of the cooling might not be linear, size of the balloon. There's all kinds of acceptable, sensible answers. Okay, last page. Megan designs a decorative glass face for a new fine art center. The glass face is made up of small triangle panes. The first 3 levels of the glass are illustrated below. The first level of the has 5 glass faces. Then the next one has 7, and the third one has 9. Okay, and each level is going to be 2 more than the previous one. So find the number of triangles in the 12th pane. Okay, so we keep adding 2 plus 2 plus 2. So we know our D value is 2. We know our first term is 5. So we can figure out how many triangles are in the 12th level by replacing U1 with 5, N with 12, and D with 2. We simplify this and we get 27 tiles. 11b. Show that the total number of triangles in S10 in the first n levels is given with this formula. Okay, so the first thing I do is I start off with this formula here, and then I'm replacing n. Oh, we don't know n. we're replacing U1 with 5. We're replacing D with 2. So if we simplify this, we get 2 times 10, which is 10, 2 times 5, which is 10. Do distributive property with the 2, we get 2n and negative 2. And now I can combine 10 minus 2, that's going to give me 8. And then I could divide both each term by 2, and we end up with 4 and just n. And then do distributive property multiplying the n, and we get this. And there I've shown it. Okay. Hence, find the total number of panes of glass in the face with 18 levels. So I'm going to replace n with 18, and I can calculate this, and I end up with 396 panes of glass. Okay, next question. Megan has 1,000 triangular panes to build with glass and does not want to have any incomplete levels. Find the maximum number of complete levels that she can build. Okay, so she's got 1,000 panes of glass. So what I'm going to do is, and we've got this formula to figure out the sum of all the panes of glass, and she doesn't want to. She's only got 1,000 panes. So if I subtract 1,000 on both sides, we've got this equation. And so what I'm going to do, let's type in this equation. X squared plus 4x minus 1,000. Okay. And then if I hit second graph, okay, so table start at 0, second graph, I'm starting at 0, and I'm going to keep going up, or moving down, and at the 29th tile, I'm at negative 43. At the 30th tile, I'm 20. So I've gone 20 over here. So once I've got to positive numbers, I have to stop. So I know that I can make 29 levels of tile. If I do 30 levels of tile, I'm going to be 20 tiles short. Okay, final question. Each triangular pane has an area of 1.84 meters squared. Find the total area of decorative glass if the maximum number of complete levels are built. Express your answer to the nearest meter. Okay, so I'm using this formula that we had before, n squared plus 4n, and we know that we've got 29 levels. So we simplify this, and so we know that we're going to be using 957 tiles. Okay, so, and now we know that our 957 tiles have an area of 1.84 meters squared, so we multiply those together, and this gives us the total area of glass panes that we're going to be using. There we go.